Alright, so here's what we got to do. I graphed this thing out. I know that it's not as pretty. I could probably put -1, -2, and so on and so forth, and then count my little ticker marks up to 6. I kind of just put my relevant points. I know that this graph is going to be here, 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 and here. Alright, here's the thing. I know how to find the zeros. The zeros of this function is -1, 1, and 2. Usually when I have that, well, first of all, I think we're going to decide that this thing kind of looks like a cubic function. So I'll probably have 3 sets of these guys right here. And then I'm going to have my x, x, and x. And what I'm going to do is I'll probably put in a +1, -1, and -2 equals 0. Now, what I'm saying here, actually maybe I should put equals f of x. I'm saying that here's my graph. I want to find the symbolic representation of that. I want to find f of x. The way I can find that is if I think to myself, well, if f of x equals to 0, that would be corresponding with these points right here, the zeros of the function. If that's the case, then this would have to be of the form +1, -1, and -2. Now you're thinking, well, why did he do the opposite? It's -1, +1, +2. Well, because this. Remember, if I said that this is equal to 0, then either, since this is multiplying by all of these other ones, either this is 0, or this is 0. Because if this first one is 0, it doesn't matter what everything else is, because 0 times what everything else is still 0. If the middle term is 0, it doesn't matter what these first and the last terms are, because those are 0 as well. And similarly, if the last term were 0, it doesn't matter what these two terms are, it would be 0 as well. So, what I would do is I would set each of these equal to 0, and so you have x plus 1 equals 0, and you end up getting x equals -1, which corresponds to that -1 right there. That's why I changed the sign in here. Now here's the problem is, and I think that we talked about this a little bit, is what is the y-intercept of this thing? If I were to multiply all of these 3 things out, I'm looking at it right now, and 1 times -1 times -2, because I'm thinking to myself that this thing is going to be, if I were to multiply this whole thing out, it would be x cubed, blah, 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 and at the end, the only pure number that you would get is 1 times -1 times -2, which would be +2. But my y-intercept is +6. So, what do I do? Well, what I can't do is this. I'll tell you what, why don't I just multiply this all out and I'll show you kind of, I don't know why I'm doing it, I guess maybe it might be a pointless exercise, but let's try it. I've got x squared minus x plus x minus 1, and that's multiplying out the first part, and x minus 2. So I have, actually, this negative and that positive cancel out, so I have x squared minus 1 times x minus 2. I'm going to FOIL that out, and so I have x cubed minus 2x minus x plus 2. Alright, so I have an x cubed minus 3x. X cubed minus 3x plus 2. I can't just simply change that 2 into a 6. Because right now, this graphs, well, it actually graphs this. Where it only goes up to 2. That's the y-intercept. But I can't simply just change that thing to a 6 and push the whole graph up, because that would change the x-intercepts. It would change the zeros of the function. It would probably push this dotted graph all the way up, and it would probably just cross maybe over here. Something like that. And that's not what we want to do. We want to keep the zeros to be the same, but what we want to do is we want to change the y-intercept to be 6. Now there's a clever way of doing it. I'll show you. It's simply right here. If I were to somehow be able to if I were to add some number out in front, so that when I multiply everything, when I multiply this times this times this times this, I'm talking about the numerical portion, just the 1, just the -1, just the -2, because remember, I'm talking about the y-intercept, which is only the pure number at the very end. if I were to multiply by some number so I can make it, instead of making it a positive 2, make it a positive 6, well, that number would be 3. Because that didn't change my zeros. Because if x equals negative 1, this whole thing would still equal 0 because I can multiply by whatever I want. And if one of them is 0, the whole thing is 0. So I don't need to worry about the pushing my graph up or down or anything. All I did really was my original, or without the 3, kind of looked like this. And then with the 3, it kind of like amplified that whole thing so that this thing got pushed up more, this thing got pushed down more, but those zeros still hit the same spot.